Okay, so if we look at another problem, in this case, say 3a squared minus 3b squared, first thing we always do is take out a common factor. So the common factor is 3, leaves us with a squared minus b squared. Okay, at this stage we need to look at how many terms there are. There are 2 terms. So we follow our diagram down. If there are 2 terms, there's only one option. Difference of 2 squares. So I follow my diagram, get to difference of 2 squares, which means we can do the difference of 2 squares to this. It is a plus b, a minus b. And we are there. Okay, so if I slide the paper down, you can see it's x squared minus 25. So when factorising, the first thing we do is look for a common factor. There is no common factor, so we look at how many terms there are. There are 1, 2. Meaning our only option is difference of 2 squares. This is a difference of 2 squares. We can see that it's x squared minus 5 squared. So we get x minus 5, x plus 5, and we're there. Okay, so here is the second question. Following our factorising flowchart, the first thing we always do is look for a common factor. In this case we have a common factor, so we're going to take that out the front. And that leaves us with x squared minus 9a squared b squared. Okay, common factor taken out. We now look at the number of terms we have. We've got 1, 2. So the only option is the difference of 2 squares. So is it a difference of 2 squares? That's a square. This is a square. So yes, it is. I'm just going to rewrite it with the squared numbers so I can see what I'm dealing with. 3ab, that's all squared there. Okay, so it's 3. I'm going to use big brackets because I like to use big brackets when I have small brackets inside. And I have x minus 3ab, x plus 3ab, and I've run out of space, which is silly, but there we go. And of course, I'm just going to rewrite that. We don't need the big brackets anymore because we can write this as x minus 3ab, x plus 3ab. And that is a bit neater, so that is the way we like it. Underline my answer nice and clear. So let's hit up some tougher questions. First things first, is there a common factor? Doesn't look like it. There's no common factor, so we're looking at the number of terms. There is 1 term, 2 terms. So we have an option of difference of 2 squares. This is a square, this is a square, and this is a square, so we do have the difference of 2 squares. The first square is a minus 3. So I'm going to use big brackets here because it's going to get a bit ugly. And I have a minus 3 minus, this square is 2 squared, b plus 5 squared. So it's actually minus 2b plus 5, close big brackets, open big brackets, a minus 3 plus 2b plus 5. Close brackets. And you see the difference of the 2 squares is here minus this one and this one plus this one. Unfortunately, we then have to simplify this up because as you see in here, we can simplify this. So this is actually a minus 3 here minus 2b minus 10. In the next one, we have a minus 3. We don't actually need the brackets anymore. Plus 2b plus 10. So we have a minus 3 minus 2b minus 10. So there's just an a. I'm going to make it just normal brackets now. Minus 2b. We have minus 3 minus 10 is minus 13. And in the next bracket we have a, no more a, so a plus 2b minus 3 plus 10 is plus 7. And that is it. Right, so cracking on, just a slightly different type here. Difficult to recognise the square, but x squared on 9 is a square and so is 1. Now first things first, common factor we don't have, so nothing to take out, but this is x on 3 squared minus 1, which of course is a square. So the difference of 2 squares is x on 3 minus 1, x on 3 plus 1, and that's all there is to that one, but it's just a matter of recognizing the 2 squared numbers there.